Hi, welcome to Full Throttle RC, presented by Warehouse Hobbies. I'm your host, Tony Castronova, and on today's show, we're going to talk about how to tune your Zenoa engine for optimum performance. So stay tuned, and we'll be right back and get started. Okay, you're in the market to build a race boat. Look no further when it comes to choosing the drive. This is the new RD1 by Enforcer. This drive is CNC made, manufactured of 6061 T6 aluminum, all done right here in the United States. The drive is awesome. It is a simple one-piece design bracket that mounts on any transom 4 inches or greater in height. It utilizes surface drive technology and is completely adjustable, means of one set screw, fine-tuned and locked in place. The drive unit itself can be easily removed by loosening 2 screws as an entire unit. It can come off to grease the cable and place back in without changing any of your settings. The rudder is set at a 2-inch race offset to the right for right-hand racing. Also includes water pickups on both sides for true water pickup in the straightaways and in the turns. The RD1 is a remarkable device. Stay tuned, and we're going to show you a clip of this drive running on our new race boat with an M6 engine at speeds over 60 miles an hour. The control, handling, and speed is just awesome. The RD1 race drive from Enforcer. Welcome back. Let's get started. This is a G260 Zenoa engine set in a display that I had made that is similar to all of our Enforcer boats and probably quite similar to yours. And this is what we're going to use as a model to show you how to properly start and tune one of these engines. Later on, we're going to go into the shop, and my son Tony's going to put one up on a dyno, and I'm going to literally have him run an engine. We won't be doing too much voiceover in that, so we will learn all the theory here, and then we'll apply that at the shop. Okay, let's get started. You don't need too many tools for this, okay? We're going to do a dry run here. We're not going to start it in the studio, but we're going to pretty much educate you on how the carburation works and on the easiest way to start these engines and what's required. And then you can take it outside and set your boat up to run a bench run with a bucket of water to the water pump, and that you can do on your own time there. Let's get started. You'll need a small screwdriver, okay, flathead screwdriver, and the directions provided with the engine, because Zenoa's directions are on the money for setting these carburetors. So if you ever get messed up during your adjustments, you can go back and refer to the page, which is page number 9 in the Zenoa booklet, and in the center, where it says G260, G231, PUM, those are the settings. Okay, we'll get into that in a second. Let's go over a couple more things before we get into the low and high needle valve adjustments. Okay, let's talk about the carburetor first. Carburetor on a G260 factory engine is equipped with a WT644. This is a big bore carburetor, okay, with a primer bulb and choke lever. Now the choke lever that you see here is one of our accessories. This comes with the ready-to-run series of Enforcer boats, and I do recommend that it's purchased. Zenoa puts a piece of fuel tubing on there, which does work, but it gets slippery and it's difficult to deal with. This is a knurled part, and it's very easy to install with one set screw, and it allows you to have total control of the choke. The top of the primer bulb right here is this little glass plastic bulb. This is what actually pulls the gasoline from the tank to the carburetor, and it's a primer. And here's how it works. The circuit of the gas tank, your feed, comes down to the bottom feed of the carburetor, and then this top outlet right here returns to the top of the neck of the tank. As you squeeze this bulb numerous times, it'll make a siphon action. It's a pump. It'll start drawing gasoline into the carburetor, and it will fill the bulb approximately half full of gasoline. Once you see the bulb fill up with gasoline, give it a few more pumps, and you'll see the gasoline returning into the neck of the carb. At this time, when you see it returning to the neck, you have the carburetor primed and ready to start. Okay, the next thing is the choke lever. And a lot of people call me and say, well, you know, I can't get my engine to run. I've tried, and it just won't start. And let me explain the choke. It is right, which is a clockwise motion, is the choke plate open. That is where the engine will run at. To start the engine or choke it, you would go counterclockwise. So the misconception, I think, is a lot of people actually go to the right, and they think they're choking the engine, and they go to the left, and the choke plate is on, and obviously you won't get an engine to run. So remember, it's simple. Counterclockwise to the left, the choke plate is on, which means your engine is choked. to the right, clockwise, would mean the plate is open, allowing air to enter the carburetor. And this is the run condition. Okay, let's address the needle valves. Okay, the needle valves in the carburetor control the metering circuits of the carburetor. There's two on these carburetors. These are pumper type carburetors. So there's two metering circuits. You have a high-end metering circuit, which is the outside screw right here, which is the one closest to the hull, and you have a low-end metering circuit or needle valve, which is towards the inside, towards the engine. And let me explain how they work. The low-end metering valve does exactly what low means, low range in performance. It's designed to work basically from 0 to mid-range, at which time the high-end needle valve picks up a secondary circuit in the carburetor from mid-range to high. Both of these must be adjusted properly. The low end can be adjusted properly on shore, but the high end must be run under load, and I'll get into that in a minute. So let's start with the low end. Over the years, I've come up with a couple different ways to describe, and anybody that's called me probably thinks it's quite comical, a couple ways to describe how to set the low end needle, and we'll get into that. Okay? Let's go, before we get the needles, let's drop down a little bit, and let's look at this large screw right here. This is your main idle screw. And all this screw does is controls how far the butterfly plate closes in the carburetor. So obviously, if the butterfly plate was to close all the way, it would restrict all the air coming in, and obviously then you couldn't draw fuel as well. As you screw this in, it allows the plate to open slightly. And that is what sets your main idle. But these needles must be set properly for this to even function properly. Okay? So generally when you purchase an engine from us or you get a Zenoa out of the box, this is pretty much set, the main screw. Let's talk about the low and high needles now. Refer to the owner's manual on the Zenoa G260. They are almost identical. I mean, these numbers they give you, and you can find it on page 9, are perfect. So if you ever get yourself a little messed up with the needle valve adjustments, you can refer to page 9 on the Zenoa owner's manual that you've got with your engine, and it will explain to you. And if you look at the center where it says G260, which is this engine, it'll show the high needle valve at 1 5/8 plus or minus 1/4. And what that means is you were to take the high needle valve, which is, again, remember we talked about that, the one closest to the hull, and you close it in, snug it. Don't ever tighten these too tight. You can hurt the seat on them. Just snug them. And they want you to open it 1 5/8 of a turn. Okay? What they're telling you there is it can now, the range or the sweet spot is somewhere plus or minus 1/4. So it really doesn't hurt to open this up, maybe go to 1 3/4 on it. And now we're at the richer end of the spectrum. It's easy to lean out. It's much easier to start on the rich end and then lean out. Now take the low, for instance. The low, they're calling for 1 turn out plus or minus 1/4 turn. So we'll do the same thing. We'll go to the low needle and we'll seat it, carefully seat it. Once you feel it snug, if you're done, and we'll take it out 1, and you know what, in this case, we're going to go 1 1/4. We're going to take advantage of the richer side of the setting. Okay, this is Zenoa's recommendations, and it is a very good chart of recommendations. Later on, I'll go into where the needles, and they actually, on an average basis, they fall. But this is a very good place to start. Okay? Okay, I turned the stand around here so I can show you how to properly start an engine and reach the pull starter. I took the spark plug out for both safety reasons here and so I could pull the engine over without too much pressure. Okay, very important. The recoil pull starter assembly on the Zenoa is an excellent device. It's compact, it's small. It's very important that these engines aren't, when they're pulled, you're not jerked from a dead stop. There's a pawl inside there, a nylon molded pawl that has to lock into a cam. So the best way to start one of these and ensure that you'll get the longest lifespan out of the starter is to actually pull the rope till you feel it grab. At which time, once it's grabbed, then you're safe to give it a pull. So you grab, pull, let it grab, and then pull. Like I said, if you jerk on it, it puts an enormous amount of stress on that pawl, and it can damage the pawl and break the pawl. Okay, let's get to starting. Assuming we have the carburetor primed, and this is a brand new day, and we set our needle valves like we just explained, we're going to prime the carburetor, and we're going to reach down to the choke lever, and we're going to turn it counterclockwise to the closed position. So now the plate is now closed in the choke. It's choking off all air entering the carburetor. Okay? This is going to, what this does by doing so is the bottom vacuum of the, when the piston goes down, is going to force draw the fuel in. And that's how you can choke an engine. But you can also flood an engine in the same manner. Okay? So let's get to that. We're going to choke the engine to the left, and we're going to reach down. You can hold your engine anywhere. You can grab it. I like to, let's put the spark plug in real quick and I'll show you a couple things. I like to grab it right around here and hold it securely. And at the same time, you want to pull. 1, maybe 2, maybe on the third pull you might feel a pop. When you feel this pop, you've now, what that's telling you is the crankcase is filled up with fuel, and it's got up on top of the piston and it's fired, but it obviously can't run because the choke is on. At that point, I find it easier to now open the choke, go all the way to the right with it. Again, let's go through the procedure starting. Usually within 2 to 3 pulls from this point, this engine will start. Okay? It's also a good idea to have the ability to have your throttle accessible. Okay, so in other words, there's a couple ways of doing it. I like to reach into the radio box, turn the radio on, turn my transmitter on, and make sure my throttle is working, and then open the throttle with the transmitter wide open and turn the receiver off. Now this is going to leave my servo positioning at wide open on the throttle. What this is going to do is allow air to come in. Now remember, we choked it and we have fuel in the crankcase. If you run into a situation to where you flood the engine or you have too much fuel, the best way to start this engine is to do as I said. Open the throttle wide open, turn the switch off, leave the throttle wide open, and pull it until the engine starts. Now, once it tries to fire, it might not fire the first time. It might ring and stall because you're loaded up in the bottom with fuel. Or it might take the second time. It won't generally go into a runaway because you'd have, in an instance where you got flooded, you'd have so much fuel in there, it couldn't burn it all within the first 2 or 3 times it fires. But then, by maybe the 3rd or 4th pull, this engine, a flooded engine, should fire right up, start clearing out, then just reach over, turn your receiver back on, and you'll regain control of your throttle. This is the way to start a flooded engine. And a flooded engine is, it generally happens if you had your choke on and you pulled it just too many times. And a good indication to prove a flooded engine is you'll pull the plug out and you'll look at it and it'll be all wet. Okay? You can blow the plug off, or you can even carefully move your spark plug wire out of the way, take a rag and pull it a few times to help take some of the gasoline out of the engine. But generally, the way I described on opening the throttle wide open, that's the proper method. Okay, this engine at this point, with everything we went through, should be running. Okay, there's no reason to pull an engine 200 times. If you're pulling and pulling and pulling and nothing's happening, okay, there's something wrong. A 2-cycle engine requires 2 things, spark and gasoline, to make something, to make a popping effect, to make a sound. If you're pulling and pulling and nothing's happened, you have 2 things. Either you don't have a spark or you don't have fuel. Or in the case that you might be abundantly flooded, would cause that. Okay, before we go out to the shop to actually run one of our engines, let's go through it one more time, starting procedures. We've set the needle valves according to Zenoa's guide. We have fuel in the primer bulb, gasoline. We have the choke to the left in the start position. We reach down, we've pulled our engine 2 or 3 times, the engine barked, popped. We reach over it, we turn the choke all the way to the right, opening the choke plate. We go back and we pull our engine until it starts. Again, at this time, I like to keep my radio system on. I want to be able to get to that throttle if I need to, or add throttle if I need to. Okay? This is the general rule of thumb how to start one of these engines. Now, we're going to go through a couple of different things about setting the needle valves and what you can do on shore. And then once I'm done, we're going to go out to the shop and we're going to run one of these things. And at that point, like I said, there's not going to be any verbiage in there, but we'll do it a couple times and show you how it's done. Okay, I get a lot of calls where guys say, hey, Tony, is it all right if I take this engine and I bench start it? And absolutely. I'd rather see you guys do some braking at your house, get familiarized with how to start your engine before you take it to the lake and attempt to do it. There's so many variables of unknowns of a new modeler that to put you in a situation where you're right at the water, even though this is very easy, just might be overwhelming. So absolutely, if you get a new boat and you want to start it and you want to do it in your garage, definitely, or outside, somewhere well ventilated, let me tell you how to do that, okay? The only thing we need to do is on a water-cooled boat is we need to make sure we have water to it, okay? Your water pump is responsible for that. At the back of the boat is your water fitting. Okay, we have what we call a transom water pickup. You might have a competitor's boat that runs a water pickup off the rudder. Irregardless of where it's located, you remove that tube at the point of the rudder or the point of the pickup. Okay? All you need is a small piece of 5/32 tubing, ID tubing, that you could plug in, take a little piece of brass tube and plug it in, and then bring that to a bucket of water and put the tube in the bottom of a bucket of water. If you had a 2 or 3 gallon bucket of water, you'd run this boat for probably 25-30 minutes before you go through all that water. Okay, very important. This has to be done before we start. With the settings that provided in the book, you can now start your engine. What I want you to do, though, on these home runs is I want you to pull, especially if you have, I don't care what rear end you have in the boat, I want the prop off the boat. On the SPD, simply unscrew the cartridge and yank the whole cartridge out. There's no reason to have a propeller on the boat. It is not safe, especially if you're moving around it. You kick it, you don't want that propeller to catch you. Then you don't need that propeller spinning 14,000 RPMs out of the water. Very, very unsafe. So let's get rid of the propeller, okay? The wet tune system, this must function with water. So there's a couple things we want to monitor as we're doing this. We want to make sure that our water pump's picking up. We want to make sure that the water is going to come out of the wet system during our break-in procedures. Okay? No need to run heavy oil. This is I've recommended this for years. If you mix with AMSOIL 100:1 and you're mixing 5 ounces per gallon, you're fine. Break it in at that. There's no need to run heavy content or scuffing oil, which that's a whole other deal. We'll go into later. These engines are too small to have to worry about scuffing a cylinder. You're dealing with a tiny little ring in there. Even though it's synthetic, yeah, it might take a little bit longer to break in. What are you talking, 1 or 2 tanks of gas? You're breaking in a tiny ring. You don't want scuffing oil. Scuffing oil will do more damage to the cylinder than good. This isn't a large racing go-kart or a dirt bike or, you know, a race car engine. Okay. Once we've got it all fueled up, we're ready to go. We've got our bucket. We've checked everything. Maybe just give it a visual check. Okay, your radio's on, your receiver's on, you've checked your throttle. Let's start our engine. So we're going to pull this engine, we're going to go through, and we're going to start it. It's going to start up. And then we can get a little bit of gas, okay? And throttle it a little bit. Within about 10 seconds, you'll see, 10, 15 seconds, you'll start to see water coming out of the pipe. Once you see water coming out of the pipe, you're fine. Now, when you're breaking in an engine, just work the throttle a little bit. We don't, no reason to scream it. Just work it a little bit. And you can do this for, you know, a good quarter tank of gasoline. Get the hang of it. Let me teach you what you can't do in the garage. You can pretty much fine-tune the low-end needle on the shore, but you cannot on the high end. And I'll go into the theory of that. When you put an engine under load, when it's sitting here, with the only load being its internal mechanism, okay, the engine doesn't require near the amount of force or energy to make it continue to run. As soon as you run an engine under load, and this goes for any engine, and that means you bear down on that crankshaft and you need the demand of energy out of that engine, the engine generally wants to lean out. It will generally lean out. So increasing gasoline into the engine, in the combustion chamber, will make more horsepower. Okay? So if you think you're going to get there and scream these engines, rev them, and try to get the most you can out of that needle valve, let's say we're talking about the high needle valve now, and you're getting it screaming, and then you go put it in the water, and the boat dies, that is because it is on a verge of being so lean, it can run its internal friction, but it cannot run the power necessary to push the momentum of that device or the boat forward, or the device that it's in. So we cannot do the high on the shore. But the low we can, and I've come over the years, over 30 years of doing this, I found a way to teach you guys what a low needle valve should sound like. And once you adjust the low end, and you get the idle set, the high end's a cakewalk. So we're going to start with the needle where Zenoa recommended. And I want to do this, and I'm going to have Tony do this a couple times so you can audibly hear what's going on. Once we get the engine started, and you break it in for a few minutes, let's start working with the low end. I want you to take your screwdriver, and as you turn this clockwise, this low end screw slowly, and I mean slowly, you're going to start leaning the gas mixture, gas and oil mixture, into the carburetor. By leaning that, you're lessening the amount going in. The engine RPMs are going to come up on their own. Okay? So as you go in with this, and I don't know of any better way to do this, you ready? You're going to hear the engine go wing, ding, 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 and it's going to get you that, you're going to hear the RPMs go up. As you continue, and you're not going to hurt the engine doing this, I want you to learn what this sounds like. As you continue to move this needle valve clockwise, it'll go up and up and up, and before it gets to a state where it's too lean to run, you're going to hear a wavering sound. It's going to start to become pronounced. You're going to hear the engine start to go woo, 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 like a wooing sound. When you hear that wooing sound, think of what's happening. You have more oxygen than gasoline. The engine's just borderline on where it can run and where it can't. So it's woo, 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 and that extra just little nth degree whoop stalls the engine. Okay. Why I want you to understand what that wooing sound is, I want you to know what the lean state sounds like. Okay? Go back to the needle valve opening, close it back to 0. Let's go back to what they recommend when I say 1 1/4. Let's start at 1 1/4, and let's do it again. And let's go through the whole thing again. Let's take that low end, start the engine, and let's turn it in. Again, to hear that the progressive engine RPMs come up, and it's going to go woo, 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 and it woos, okay? Now, you can let it stall, or here's what we want to do. When we get to the wooing, if we take that wooing state and we back about 1/4 turn back, you will hear that carburetor fatten up. That engine will fatten right up and start running really good. That is the approximate perfect place for the low-end needle. So we take it and close it slowly till we get to that wooing sound, and when we hear the wooing sound, we back off about 1/4 turn. Okay? That's pretty good. Okay, now we have the engine running. We're going through break-in. We're in our garage or outside, or we snuck it in the pool, and we're sitting there watching it run and anticipating how fast your enforcer boat's going to go. Let's let this go through. Let's get through a tank, a half a tank of gas. Be great, okay, for break-in. At that point, that's where you can start to work with your main idle adjust, and you can get this engine to idle down, relatively low. Now, another mistake commonly made: the Zenoa engine. It's considered, I've heard it a million times, a stock engine out of the box. No such thing. A stock engine out of the box would be referred to when I was doing the weed eater engines of the last 20 years, where we were taking weed eater engines off a stick and putting them in a model boat. That's a stock engine. That's an engine that makes about 1.1 horsepower. The engines coming out of the box today, the G260, is almost 3 horsepower. It's rated at 2.9 horsepower, and I've proved that it's on the money from what Zenoa claims. That is 3 times of what a standard stock engine is. These are aggressively modified engines from the factory with high exhaust timing, low intake timing, multiple transfer ports, higher compression, and these are running engines. And why I'm telling you this is a lot of people have this idea that they think this thing is going to pop, and it's not going to happen. When you have aggressive timing on an engine and small flywheels to get the maximum performance out of an engine, the last thing you're going to do is make it idle at 1,000 RPMs. It's the large flywheels that create the inertia to allow that. We don't have that in these engines. And plus, with the timings the way they are, if we tried to idle them too low, you would get an abundant amount of fuel would build up in the crank case, and then it would go up through. It would load the engine up and kill the engine. So, with that being said, when I started developing these clutches, I worked with the fact that we knew these engines like to run around 4,000, 5,000 RPMs, especially the modified ones we do. So we developed clutches that would engage at 6,500. So don't be afraid to let this engine idle up, because it's going to run at its best at a higher idle state. And as long as the propeller, or the clutch in this case, isn't kicking in, you're fine. So you can adjust this idle down to just where the clutch disengages. And you can literally watch the clutch. You can hear it. You can actually hear it go into maybe a little dinging sound, or you'll see the clutch drum just slow down or stop. And at that point, set an idle. Find yourself an idle that works with you and works with your clutch, and don't expect the engine to idle like a Harley at 800 RPMs. This isn't going to happen. Or if you do get it to idle low, it's not going to idle for long. And the last thing you want to do is be idling up in the water and your boat stalls on you, and that's called loading up. Okay. Another good rule of thumb with these engines are, because they're modified the way they are, when you do let them idle, don't let them idle too long, even out in the water. Give it a blip, give it a burp, blow it out. Let's get the fuel up and burn, and the fuel that doesn't burn, let's get it out the exhaust system. Let's not let the engine load up. These are fairly modified engines, but it's a misconception when you hear the word stock. Stock meaning nobody's touched it from the time it came out of the box, but in design, they are not a stock engine. Okay, remember we talked about we couldn't do the high end on the shore. This is true, okay? So let's set the high end like we did to the Zenoa specifications to the rich side. And at this point we have to run the boat, because as you put the boat under load, this engine and the high end, now we have the low end set, the high end will want to lean out on you. So We're going to start that, and we have to physically run the boat to do this. And without me going to the water right now, I'll touch on that. It's pretty simple. We're going to get, we know our boat's broken in right. We've got a good tank of gas through it. Engine idle's great. You are way ahead of the game at this point. Okay? Go to the lake. Get everything out. Don't thrash. Don't be in a hurry. Everything must be safe. Keep this in the back of your head. We have our cable greased up. We've put it in the boat. We've greased up our bell housing in the front. We're ready to go. We have gasoline in the tank, and when you put your gas in, follow directions. There's no need to be up past this neck. We like to keep the gasoline down at this level, under the neck. There's plenty of gasoline in it. No reason to have to get any unnecessary gasoline to splash up in the hull. Okay, we start the engine, we run it, we put the boat in the water. We wait a few seconds till we see water coming out of the pipe. Give it a little bit of throttle. Let the boat start going. At this point, this boat's going to run. We know we have the low end set, so that's going to be no problem. And you might, what we're going to have is a fat or rich needle set in the top end. And there's nothing wrong with this. Let the boat run around a couple laps. Keep it close. You know, keep away from obstacles. You shouldn't be running in a waterway where there's a lot of obstacles. But keep it close. Keep it 50, 100 feet away from you. And make circles till you familiarize yourself with it. Now, once you familiarize yourself with the way the boat handles the left and right, if you're happy with everything, you might have to set your trims on your rudder. That's all done on your radio. You can do that all on board now on the radio system. You can mechanically do it back here, but generally when you buy a ready-to-run boat, we've already done that at the factory, so any type of tweaking will be done on the transmitter. Again, we set everything at about 60% of the 100% that it'll operate. If you want more, you go back, make sure you've read your radio transmitter instructions so you know how to do this. And do these procedures. So you've got a little bit to do before you worry about how fast your boat will go. Once you're happy with the way it drives, you can start to lean out the high end. And this is how it's done. Bring your boat in, and when you're bringing your boat in the shore, never come in straight. I want you to skirt the shore. Look, we have great equipment today. But we have a $125 radio system. Anything could go wrong. You could have a throttle hang up. You could have a servo short out. You could have a radio just die. In the case that happens, by skirting the shoreline, if something happened this way, the worst you can do is do damage to your boat. There would be nothing worse than a boat coming in at you at 40, 50 miles an hour and trying to stop a 22-pound fiberglass missile. Okay? So we don't want to do that. We want to skirt the shoreline. As you come in, skirt the shoreline. Okay? You can, now there's two actions that you can do here. You can take the boat out of the water and shut it off and always bow high so the water comes out of the exhaust. Or you can reach in, pull the hatch cover up, reach in, and try to adjust your needle valve this way, which I do. And what you do is, if you're going to do that, take your cover off, let the boat run, turn it in maybe an eighth of a turn, put it back on, go run the boat again. You're going to find that every time you do this, the boat's going to pick up speed progressively, more and more and more and more. You're going to come back in and get to the point where you're going to turn it an eighth of an inch, and you're going to pull that trigger, and you're going to say, oh my God, I can't believe how fast this thing goes. Now, there will also come a point in time where the engine could go lean, just as what we did with the low end. Only when they go lean under load, the boat's generally going to die. Okay? So the key to this is to find the right needle adjustment to give you the maximum amount of speed in the water conditions, the size of the hull you have. Okay? And by doing so, it's incremental, small, 1/8 inch right-hand clockwise adjustments running a couple laps between each. Now, let's say you get to the point where it's running great and you say, this thing's fast, I want to go faster, and you go that eighth of a minute turn too much. If you give it throttle and immediately the engine goes, here's two things that's going to happen. When you're borderline lean, you're going to go out and run, and that boat's going to fly. In about 1 or 2 laps, it's going to slow down all by it's just a little bit. You're going to see it drop off, maybe 5, 6 miles an hour, but you haven't done anything with the throttle. What that's telling you that is the engine is now gone too lean. It's heating up a little bit. You have too little amount of fuel to make too little amount of power to run the boat. Okay? At that point, you bring it back in, go back to your last setup. That is ideal for that situation. Now, let's say you overshot it. Let's say you went a quarter turn, you completely overshot it, and you nailed it on the transmitter, and the boat just went boom and died. That's exactly what's happened. The transition, remember I told you about the two-part metering system to these carburetors? The transition from low to high cannot be made from mid to high because you're too lean now on the high end. So yeah, the engine might idle great, and it might run up to 25 miles an hour great, but a little bit more, you can't make that transition over because you're too lean on the high end. So now we got to go back to the high end again and richen it back up till we find the sweet spot. This is the part that might take an hour. And if you don't know this, an hour, couple hours to learn how to do this. If you're a master at this, it's minutes. Okay. If you leave everything the way it comes from the factory, and you with the right same prop on it, 75 millimeter, for instance, for our boats, the settings are going to be very similar, exactly as I described. If you start changing propellers, that also changes the demands of the engine. Larger propellers, more power. Smaller propellers, you might get a little leaner. Again, efficiency, also propeller efficiency is very important. You can't keep downsizing propellers thinking you're going to go faster and faster and faster. You're going to get to a point where you downsize to where that particular propeller cannot push the mass forward, and rather than the propeller working its way like a screw through the water, it will literally, the boat will hold enough pressure back where the prop will blow out. So generally, if you're a new boater, run the way we set you up. It's optimum equipment. I was involved with those when we were designing those big props. It's optimum for the boat. This will get you your feet wet, so to speak. You'll understand how to do this properly. Okay? And if you do all this, you will be real proficient in no time at all. I promise we go to the shop, and we will, honest. And I know this show's running a little bit overtime. Chris told me we're a little bit going over. I want to go through some safety stuff before we go to the shop. That's very important. I blew by this whole thing so fast. I want to make sure we all realize we're working with gasoline. It can be very, very dangerous stuff. Okay, couldn't find the right word for that. Okay, remember we talked about being flooded, and I said, hey, when you're flooded, you want to check. You want to make sure you got a spark. You got to make sure you have gasoline. This is all important. Most important, though, as we do this is remember something. We have a live spark plug here. When we put this cap back on this plug and we go to ground it and pull the string, and we are full of gasoline, and we're in the crankcase, it's all over the engine, and we might want to inadvertently ground it to the top of the engine and pull it to see if we got a spark. The spark is open in gasoline, guys. There's enough vapor there to cause an incredible fire, and fast, okay? And I've had it happen, so it does happen. If we're going to check this, make sure you got a rag, you wipe this down real good, make sure you pull the engine over a few times in the rag to get as much of the gasoline out, and then when you do go to check a plug, check it in an area that has no gasoline. You're going to have to ground the plug. Ground it on an area of the engine that is least likely that anything like that can happen. And I needed to go through that with you. And we talked about the propellers. Very important, guys. Don't test these engines outside with a propeller on them. If you're going to be running an engine and move it around the boat, get rid of it. Take the prop off. Let's be safe. That's pretty much what's involved with starting a Zenoa engine, or pretty much basically any two-cycle engine like this. They're all, and every engine has its own little quirks. You might find yours takes 2 pulls with the choke, and then one that open, and a little bit of gas and it fires. And the other guys might take 1 pull with the choke. Every engine has its own little thing you might figure out, and you might have your own individual way of doing it. But the biggest problem, again, if I haven't heard this a million times, my engine's not running, I don't have a spark. Yes, you probably have a spark. The spark is very light on these, and when you check them, it's a very weak spark. These aren't car coils. What generally happens is that the biggest problem is they load up because you flooded them, and then obviously you have so much fuel in the engine it can't burn it. And the best way to start it is open that throttle wide open, hold it wide open, and pull the engine if it takes 20 pulls till it starts. Now, if you're working on an engine like we talked about in the show, you're pulling, and you check the obvious. Check fuel in, check a spark. You either have to have something missing for this engine not to make some sort of a sound. So if you're pulling for a day and a half, pick up the phone and call me. There's something wrong. Okay? There's no reason for that. No blisters. I've heard that too. I don't think I've ever gotten a blister starting a small engine like this. Okay? All right. In a couple minutes, we're going to move our equipment outside. We're going to go into our factory. We'll probably use the smaller camera, so the quality won't be as high as the TV camera we use here. But I'm going to go out in the shop with my son, Tony, and we're going to set one of the G260s right out of the box up and we're going to put it on the conventional inertia dyno. We're not going to use the water brake dyno. We're going to use the dyno that replicates the propeller, so we can load it to the propeller, and this will allow us to run the engine throughout the whole gamut. This is old Betsy. It's a dyno that we built 20 years ago, and we talked about selling it when we got the new one, but I don't have the heart to do it. We still use it every day. So we'll see you in the shop, and this I hope would be a great episode. I hope I've taught you guys something about this. This is episode number 8 on tuning your Zenoa engine, and tune in and see me in a couple minutes in the shop, and we'll get this thing finished up. And thanks for joining us today on Full Throttle RC, presented by Warehouse Hobbies. I'm your host, Tony Castronovo.